Welcome to identifying perfect squares and cubes. So let's start with the definition of a perfect cube. Perfect cube. Perfect cube is when a number is the cube of another number. Okay, so for example, 8 is 2 cubed. Okay, because 2 times 2 times 2 is 8. Make sense? Okay, a perfect square is pretty much the same thing. N equals a squared, but just squared. Okay, so for example, 4 equals 2 squared because 2 times 2 is 4. Okay, so bear in mind that a cube means there's 3 2's, or 3 of the number, and a square means there's 2 of the number. Okay, let's go over here. I'm just going to move this to the side. Okay, here. Okay, so let's look at 125. So the first thing that we're going to have to do is we're going to have to set up a prime factorization, okay? Because we don't know, we can't assume that we know, okay? We have to show all the work possible, okay? Let me just rewrite that. 125, okay, so the lowest number that goes into 125 would be 5. Then we're left with 25. Okay, you can do these divisions by yourself here. Okay, 5, 5. So 125 equals 5 times 5 times 5. Okay, because here we're just multiplying. Okay, so notice anything? There's 3 5s. So that means 125 equals 5 to the 3, or 5 cubed. Okay, that's our answer. Okay, that's all the work they have to do for a question like this. So look at this, 49. So we're going to put 49 into a prime factorization. So the lowest number that goes into 49 is 7, and we're left with 7. Okay, so 49 equals 7 multiplied by 7. Okay, because this is just a multiplication. And because there's 2 7's here, that is 7 squared. So 49 equals 7 squared. Okay, so remember, we're identifying perfect squares and cubes. Okay, so 125 here equals 5 cubed, 49 equals 7 squared, and that's all the work that you really need to show. So look at 729. So 729, okay, let's see, the smallest number that goes into 729 is 3. Then we're left with 729 divided by 3 is 2, 120, 4, and there's 9, 3, 2, 4, 3, okay? So, also do this division by yourself, okay? Left with 2, 4, 3, and then we're going to divide by 3 again. So then we're left with 81, can divide by 3 again, we're left with 27. Okay, I'm going really fast here, so make sure to pause and do all these divisions and this prime factorization completely by yourself, okay? Divide by 3, that's 9, divide by 3 again, that's 3, okay? So 729 equals 3 times 3 times 3 times 3 times 3 times 3, okay? Now you might be tempted to say, oh, okay, so that means 729 equals 1, 2, 3, 4, 5, 6, 3 to the 6. But look again, the scale that we're looking at is perfect squares and perfect cubes. 3 to the power 6 is not a perfect square, and it's not a square, and it's not a cube, okay? We want to put this in a form where it's a square or where it's a cube, okay? So let's group this. There's a couple ways we can do this, okay? So take a look at this. Imagine that I put imaginary brackets around here and around here, okay? So 3 times 3 times 3 is 27, multiplied by 3 times 3 times 3 is 27. So now that we have two 27s, we can say that 729 is 27 squared. Okay, but we're not done here, okay? So let's take a look again. 3 times 3 times 3 times 3 times 3 times 3 equals 729. Now, let's take a look at this. You can do. There's 3 sections here of 2. Okay. this is 9. This is 9, right? Imagine the brackets around here. This becomes 9. 9 times 9 times 9. Okay. And because there's 3 9s here, we can say 729 equals 9 cubed. Okay? So our two answers, we have two answers for this one. That would be 729 is 27 squared, and 729 is 9 cubed. Okay? We want to identify if they're both squares or cubes. Okay? We can't just say, okay, 729 is 9 cubed, and stop. Okay? We also have to check if there's a square. Let's look at 90. Okay? So we're going to take 90, put it in a prime factorization. You can divide it by 2, and then we're left with 45. You can divide by 3, and we're left with 15. You can divide by 3 again, and you're left with 5. Okay? So 90 equals 2 times 3 times 3 times 5. Okay? Is there any way we can arrange this to make it a cube or a square? Let's see. 2 times 3, 3 times 5. No, that doesn't work because these are two different terms. 3 times 3 and 2 times 5, that's 9 times 10. That doesn't work either. So what this means is you will write a statement saying 90 is neither a perfect square nor a perfect cube. Okay? Box your answer. That's it. Okay, and that's identifying perfect squares and cubes.